We are witnessing a trillion-dollar race for software supremacy, but the lead is measured in inches. On the Arena ELO leaderboard, the top American model, Claude 4.6, leads its Chinese counterpart, Seed 2.0, by a margin of only 39 points. The assumption driving global markets is that whoever wins this software race will secure the primary lever of 21st century geopolitical power. In 2025, American AI firms attracted $285.9 billion in private investment, 23 times China's capital. But Beijing bypasses this financial moat, deploying over $300 billion through state-guided funds, while architectures like DeepSeek R1 achieve frontier-level logic at a fraction of legacy Western training costs. Because these algorithmic breakthroughs diffuse almost instantly, the technical performance gap has narrowed to a state of equilibrium. Software alone has not provided either nation with a permanent advantage. A digital brain is limited by its inability to interact with the physical environment. Without a body, a model can solve complex physics equations, but it cannot pick up a wrench. While Western investment has targeted generative software, the physical hardware required to embody that intelligence has received significantly less attention. In the realm of robotics, the competition is not an alternating tie. Instead, the United States is operating with a structural manufacturing deficit that threatens its industrial competitiveness. The focus on a digital mind has left the U.S. without a domestic path to build the machines that software is meant to control. To see the actual scoreboard of this competition, you have to look at the factory floor. China has used a whole-of-nation industrial strategy to build a concentration of manufacturing capacity. This visualization shows 2024 industrial robot installations. China deployed 295,000 units, 9 times the United States' 34,000. This created a massive disparity. China operates over 2 million robots, nearly half the world's robotic workforce. This fleet acts as a massive data collection engine. Millions of machines are constantly feeding real-world training data back to Chinese researchers, allowing them to optimize automation software at a scale Western firms cannot replicate. The physical presence of these robots gives Beijing the ability to train and refine physical artificial intelligence in the environment where it will actually work. The next phase of this competition is humanoid robotics, where software-defined cognitive architectures are embedded into bipedal and dexterous forms. The United States currently maintains a lead in the design of these systems, hosting elite research hubs and pioneering startups that define how these robots think. However, without a domestic component supply chain, American firms are forced into expensive vertical integration. They must fabricate their own actuators, their own custom motors and sensors entirely in-house. China holds a near monopoly on the production of high-torque actuators, the mechanical muscles that allow a humanoid to move and lift. Actuators comprise half of the bill of materials for a humanoid robot. By mass manufacturing these parts, Chinese firms can produce hardware that is 80% as capable as American designs for only 70% of the price. This gap exists because American venture capital is structurally disincentivized from funding assembly plants, while Beijing's 15th five-year plan has placed robotics at the center of its modern industrial system. American robotic software is world-leading, but its commercialization is limited by a domestic manufacturing ecosystem that cannot build the parts. Digital technologies are difficult to defend. AI algorithms and software architectures leak through open-source channels almost as soon as they are developed. But the physical world is different. You cannot open-source a factory, and you cannot download a dense industrial supply chain. It takes decades of sustained capital to build the manufacturing clusters China now controls. This physical edge is structurally entrenched. This risk matrix from the Australian Strategic Policy Institute classifies advanced robotics as a high-technology monopoly risk. China now produces more than 3 times the high-impact research of its nearest competitor in this field. In response, American policymakers have begun forming national commissions to assess the domestic industrial base and find ways to restore manufacturing competitiveness. The winner of this technology competition will not be the nation that merely codes the smartest artificial brain, but the nation that controls the physical capacity to build its body.